Hi, this is Miss Linton, and this is 7th period support for APBio. Say hi. Hi. And we are going to be reviewing Chapter 8, Cellular Respiration. Okay, so first off, I want to remind you, we did an essay review. We did an essay review yesterday for Unit 2 essays, and I posted that on YouTube, and I recommend that you take advantage of that because that will review the essays that you need to know. How many of you were here for that? Good job. All right. So a couple of big things we need. You need to know the big ticket, obviously, equation for cellular respiration. You want to know what's getting oxidized and what gets reduced. Overall, cellular respiration, would you consider it to be an exergonic or an endergonic reaction overall? Exergonic. You're releasing the energy out of what? Glucose in many small steps, right? Now, do we get all the energy out of glucose that we can possibly get? No. No. How efficient are we? 39%. And that's only if we have what? Oxygen. Okay? So when you do who does cellular respiration? Also. Now, there are two categories of cellular respiration. What are they? Aerobic and anaerobic. When I walk away, theoretically, having done anaerobic respiration, how much ATP could I have? 2. That's not very much, right? And the reason is, the only way you make ATP, wait, think about it, don't shout it out, just think for a second. The only way you make ATP when you do anaerobic respiration is through, I'm looking for something more specific, substrate level phosphorylation. And when is that ATP made? During what? Now you can tell me the specific reaction. No. Glycolysis. Pete, stop. There is right there. There's some learning we need to address. Some serious learning we need to address. Let's see, is this that one? No, I don't have it. Okay, so when we start out and we do glycolysis, who does glycolysis? And where do you do it? In the cytoplasm. Technically the cytosol. You use glucose and you do what? To what? To pyruvate. Yes. And along the way you will make what? 2 ATP, but you know you make 4, but you have to input 2. What else do you make? 2 NAD reduced. Okay? Now, if you have no O2, then you will do what? Fermentation. How many choices do you have? 2. Either way, you're going to take that pyruvate and either reduce it to what? Lactic acid. Or what? Alcohol. Or reduce it. Alcohol. Wait, ouch. There's an H in there. Is that right? Yeah, that's right. Amazing that is right. Okay, or you reduce it into alcohol plus CO2. Yes? Yeah. 2 of them. But what that does is it takes the NAD that was reduced right here, this NAD, and it makes it, either way, it's going to make it what? NAD ox. That is the only reason you ferment. No other reason to ferment. Because you need to regenerate NAD ox. So, because when you do that step, when you reduce the NAD, that's why you get to net out 2 ATP. If you run out of oxidized NAD, you're out of luck, right? Now, if we had, where does fermentation take place? Cytoplasm, exactly. If you have oxygen, what's your next step called? No. Transition prep, right? And you take the pyruvate and you convert it into what? 2-acetyl-CoA. 1 away. What else do you make when you do that? 2 NAD reduced, and yes, you make 2 CO2. Do you agree with that? Okay, then once you're done with making the, acetyl-CoA, oh guys, we're going to tour group here just for a brief moment here, okay? Just pause. Okay, we're back. If I have oxygen, I'm doing transition prep, okay? You're going to form 2 reduced NADs, 2 CO2s. What's the next step? Krebs cycle. How many times are we going to do it? Twice. Why? 2 acetyl-CoAs. Good. Each time I do the Krebs cycle, just total, give me total. Every time I do a Krebs cycle, how many NADs will I generate? 3. Perfect. Do you know where those are? Where? There? They're there. Reduce an NAD, reduce an NAD. No. Do the bit, reduce an NAD. Good. All right. What else do I get out of this? 2 FADs. 2 or 1? 1. Yes. Yeah. Each cycle. What else do I get? How many? 2. What else do I get? 2 ATP. Okay, then you do this times 2, right, for your total. Do you agree with me on that? Okay, so I'm going to take all of this and say times 2, right? Then I take all my reduced NADs and FADs, and those will be, right, those will be here, 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 right? How many total NADs will we have? 10. How many FADs will we have? 2. Okay? Those I'm going to take to the top of the ETC. Technically, am I taking them all to the top? No, some I go what? Partway down. Who goes partway down? And?
The NADs from glycolysis.
Boom. NADs from glycolysis. Perfect. Okay? Theoretically, each NAD will generate 3 ATP and each FAD will generate 2. But in reality, it's really 2.5, 1.5. Perfect. Okay? Now, it behooves us at this time to talk about the 3 types of phosphorylation. We do 2 of them in cellular respiration. What are the 2 we do in cellular respiration? Substrate level. Where? Glycolysis and Krebs cycle. Glycolysis and Krebs. Okay, what's their substrate level? What's the other one? Oxidative phosphorylation. When does that happen? In the ETC. In the ETC. Good. What is the third way? Photophosphorylation, and that happens in the what part? Light reaction. Perfect. Okay, we'll do the song once, and then I have a bunch of questions. Yes. I think. Where are they? Go in is your favorite after-school snack. I don't know. Okay. Let's do the song. I don't know if this is where I put all the questions. Okay, come back to me. What's the whole thing called? Cellular respiration. First step, glycolysis. Who does it? All cells. Where do they do it? In the cytoplasm. What do you start out with? Glucose. How many carbons? 6. What are we going to do? Break it down. How many steps? 10. How many enzymes? 10. What are these called? 2 pyruvic acids. And you reduce some NAD and make some ATP. 2. Oh, we have plenty of oxygen. What should we do? Aerobic respiration. What's the next step called? Transition prep. Here we go. And you reduce some NAD and 2 acetyl-CoA, put 1 away. What's the next step called? How many times are we going to do it? Why? 2. Good. 2 plus 4 is 6. Do the bit, get 5. Do the bit, get 4. Make an ATP, reduce an NAD, reduce an NAD, and 2 plus 4 is 6. Do the bit, get 5. Do the bit, get 4. Make an ATP, reduce an FAD, reduce an NAD, and stop. Gather all your reduced NADs and FADs and take them to the top of the ETC. Na-na-na-na-na-na-na-na. Reductase, reductase, cytochrome oxidase, and you make some ATP. A lot of it, a lot of it, a lot of it, or a lot of it, a lot of it. Who catch electrons at the bottom? Oxygen forming water. Oh no, we don't have any oxygen. No.
Fermentation.
2 pyruvic acids, and you reduce some NAD and make some ATP. 2, oh no, we don't have any oxygen. What are we going to do? Fermentation. How many choices do we have? 2. You and I make lactic acid. Makes our muscles sore. Plants and yeast makes alcohol. Either way, you oxidize your NAD. Let's talk about some key things here. Glycolysis occurs in the cytoplasm. We walk away with 2 ATP and 2 reduced NAD. If we have oxygen, we will move into the mitochondria. Where? The matrix. We're in the matrix of the mitochondria, and this is where we're going to do transition prep. We're going to further oxidize pyruvate into acetyl-CoA, releasing carbon dioxide, reducing 2 NAD, not making any ATP, not needing any oxygen. We haven't needed it yet. After transition, we're moving into the Krebs cycle. Another name for it? Citric acid. We're still in the matrix of the mitochondria. How many times are we going to do it? Twice. We are going to completely oxidize the 2 acetyl-CoAs, oxidize them and be done with them. And then what we're going to do is we're going to generate some NADs and some FADs and do a little substrate level phosphorylation of some ATP. And then we're going to gather all our reduced NADs and FADs and along the cristae of the mitochondria, which is the outline of the matrix. You with me? Outline the matrix. What's on the other side of the cristae? Intermembrane space, but it's still within the mitochondria, right? Okay, so at the electron transport chain, you're going to feed it high energy electrons, and as those electrons cool off energetically, that some at reductase, cytochrome oxidase. They have, when they get a little energy from an electron, they have enough energy to take a hydrogen ion from the matrix and put it into the intermembrane space. FAD comes in a little bit lower, so it only comes in at reductase, cytochrome oxidase, and takes advantage of those two. Again, taking hydrogen ions from the matrix and concentrating them into the intermembrane space, generating a chemiosmotic gradient. The hydrogens want to move back into the matrix, moving through what? ATP synthase complex, generating ATP. If we have no oxygen, after glycolysis, we will follow that up with fermentation. That's all part of anaerobic respiration, right? And the byproducts there, the only reason we make alcohol or lactic acid is so we can oxidize the NAD so we can reuse it in glycolysis again. Got it? Questions? Feeling smart? Yes?
So just to clarify, the chemiosmotic gradient is from low to high or high to low?
Chemiosmotic gradient just means I have a difference. I've got water up on this side and water low on this side, so the water wants to move through. And it's a difference in concentration, charge, pH. I don't remember if this has like the 10 question one or not. Maybe it's a 1 question. Oh, it's 5 questions. Give it a go. Okay, guys, let's finish up, please. Greatest contributor of electrons. Stop for a minute. Definitely the citric acid cycle, right? Because from it I get how many NADs? 6. That's a lot of electrons. And how many FADs? 2. That's a lot of electrons. Oxygen does not contribute electrons to the citric acid cycle at all. At all. Glycolysis only contributes 2 reduced NADs, and usually they're weak anyway. They go in as FAD status. So not glycolysis. Check with your bio buddies, see if they need a little shame or they're doing okay. Doing well. All right. Stop. You're very chatty. Substrate level phosphorylation takes place in glycolysis and citric acid. We've already talked about that, so I'm surprised that 2 of you said the electron transport chain. That is not substrate level phosphorylation. That's using and generating a gradient in order to generate ATP. Substrate level is just a handoff that happens only in glycolysis and Krebs. Yes?
What's the other,
Yeah, I'm listening.
what's the other phosphorylation? Not the substrate.
Oxidative phosphorylation takes place in the electron transport chain, and then photophosphorylation in the electron transport chain of photosynthesis. Okay? Next, 3. The oxygen required by cellular respiration is reduced and becomes part of which molecule? It becomes part of water. Somebody said carbon dioxide. The carbon dioxide is given off in transition prep in the Krebs cycle. The oxygen doesn't play any role in there, right? So not there. Number 4. Oh, yeah, 10. 6. What's the number 6 for? Yes.
Krebs cycle.
Krebs cycle. Thank you. Yes. 3 per ATP. Theoretically, we know it's closer to 2. Yes. Okay. Any other questions or concerns? Yes. I'm listening.
So just to clarify, in glycolysis, a net total of 2 ATPs are produced.
Yes.
And then none are made in the prep. And
Right.
then in the Krebs cycle, because it's twice, it's 6. So where are the other from?
You switch between NADs and ATPs in your explanation.
Oh, I'm sorry. So just ATPs.
You want to know? Okay, so let's just chart the ATPs. Okay, let's just chart the ATPs in our head. Okay, so glycolysis, does glycolysis get me any ATPs?
2.
Yes, 2. Good. Does transition prep get me any ATPs? No. I was making it true false for some reason. Transition prep equals 0. Krebs cycle.
2.
Do you agree with that? Yeah. 2. Electron transport chain. We've got multiple things we need to talk about there, right? We have 8 full strength NADs, right? Where am I getting those 8 full strengths from?
The Krebs cycle?
No. Full strength NADs. Where am I getting them? Krebs. Oh. Yes. No. I heard somebody say glycolysis is what I was saying no to. Maybe not. Somebody said that? Okay, good. So we got that straight. So we have 6 from Krebs and
2 from transition prep.
So how many is that total? 8. Do the bit, reduce an NAD, do the bit, reduce an NAD. 1, 2, 3, 4, 5, 6. Reduce some NAD. 2. There. 6, 8. 8 times 3 is going to give me what? 24 ATP. Right? Now, how many FADs do I get? 2. So 2 times what? This is NAD. This is FAD. 2 times what? 2 is 4 ATP. Then we have the 2 NADs from glycolysis, right? So that's 2 times either 2 or 3. So that will either get us 4 or 6. Sweetheart, you asked the question. You follow?
Yeah.
Okay. Any other questions on that? Good? All right. Have great evenings. If you get hungry, have a piece of toast. Know that I love you.